Welcome back. So now we're going to be solving some quadratic equations where our equation is not in standard form. All right, so here's our first one. We want to solve 10 equals x squared minus 3x. You can't solve it like that, right? There's no 10 product rule. There's only a 0 product rule. So you do have to move everything to one side, right, so that your equation is equal to 0. Also, you want to keep x squared positive. Don't make your x squared negative, right? So instead of moving x squared and negative 3x, let's just move the 10. Right? Nobody says we can't just move the 10. Right? So somewhere my negative didn't appear. So we're going to subtract 10 from both sides. Now we have 0 equals x squared minus 3x minus 10. Perfectly fine to have the 0 on the left. Right? Now we've got it in standard form. That's good enough. I mean, you could flip it and put the 0 on the other side, but that doesn't matter which side the 0 is on. It's the same equation. We just want to make sure we have the squared term, and then we have the x term, and then the constant, and the whole thing is equal to 0. All right, so our a is equal to 1, our b is negative 3, and c is negative 10. So we're going to multiply 1 times negative 10, a times c. And we want two numbers that multiply to give us 1 times negative 10, or negative 10, and add to give us our b term of negative 3. Well, 10 doesn't have a whole lot of factors. Matter of fact, it has two pairs, 1 and 10 and 5 and 2. Well, 1 and 10 is not right. They're not 3 apart. 5 and 2 are the right pair, right? So we have, since it adds to be a negative 3, it's going to be negative 5 and positive 2. Those multiply to give you negative 10. Negative 5 and positive 2 add to give you negative 3. So now we're going to replace that middle term, that bx, as the sum of the two terms whose coefficients are the integers you've just found. That means we're going to replace the negative 3x with a negative 5x and a positive 2x. Right? And the ordering of those two doesn't matter, but whoever's first and second are going to be a group, and whoever's third and fourth are going to be a group. And then we'll apply the greatest common factor. All right, greatest common factor for x squared and negative 5x is an x. X squared divided by x is x. Negative 5x divided by x is a negative 5. Greatest common factor for 2x and negative 10 is a 2. 2x divided by 2 is x. And negative 10 divided by 2 is negative 5. So that repeating x minus 5 is one factor. And what we pulled out, the x plus 2, is the other. And now we just use our 0 product rule to get our two solutions. So we have x minus 5 equals 0 and x plus 2 equals 0. A nice easy solve. Add 5 to both sides. X is 5. Subtract 2 from both sides. X is negative 2. And that's it. We're done. Right? Easy peasy, right? All right, let's look at another one. We have 4x squared equals 81. This one, by the way, is in your notes. All right, we got to move the constant term. Don't move the x squared because you want that to stay positive. Instead, let's move the 81. So we'll subtract 81 from both sides. And we have 4x squared minus 81 is equal to 0. We're going to multiply, oh, so by the way, our a is 4. There's no x. If there's no x, it is 0. And c is negative 81. So we have 4 times negative 81, a times c, and that is negative 324. So we need two numbers that multiplied to equal negative 324, but add to equal 0. Well, the only way you're going to get two numbers to multiply to something and add to 0 is if you have two numbers. In this case, if we have two numbers that are opposites. Right? So when we're factoring, if whatever our product is, if that b is 0, that product has to be the product of two numbers that are exactly the same, except for their sign, and their sum is going to be exactly the same except for their sign. 324 is a perfect square. It's 18 times 18. So our two numbers are going to be negative 18 and positive 18. That'll multiply to give us negative 324, and it will add to give us 0. So on these factoring, Anytime you get b equaling 0, right, you're going to be thinking that AC has got to be a perfect square, and it's going to be the square root, right? The positive square root times the negative square root, and the positive square root plus the negative square root, right? It'll always work out that way when we're factoring. That's the only way it'll work out. All right, so we want to rewrite that middle term, that 0x, as the sum of the two terms whose coefficients are the integers we just found, negative 18x and positive 18x. Oh, I don't know why I put another plus. All right, so now we'll first two become a group, second two become a group, negative 18 and positive 18. All right, and we plot our greatest common factor. All right, so 4 and 18 are both divisible by 2. Do not pull out the 4. 18 is not evenly divisible by 4, and they both have an x. So our greatest common factor is 2x. 4x squared divided by 2x is 2x. Negative 18x divided by 2x is going to be negative 9. All right, greatest common factor for 18 and negative 18x and negative 81 is 9. 18x divided by 9 is 2x. Negative 81 divided by 9 is negative 9. All right, so that repeating 2x minus 9 is one factor, and what we pulled out, 2x plus 9, is the other. By the way, this is what's called a difference of squares. So a difference of squares is when we have a perfect square. Kind of write, and where can I write it? I'll write it at the top. So this ends up being a difference of squares. And what that means is we have a perfect square minus a perfect square. All right, so 4x squared, that's a perfect square. And 81's a perfect square. And there's a subtraction sign. I'm going to write that better. Anytime we have a difference of squares, when we factor it, it's always going to be square root plus square root and square root minus square root, right? So we do have, on the second term, it's square root plus square root, and the first one is square root minus square root, right? So just a little helpful hint there. However, factor by grouping always works as well. All right, so we just set these equal to 0 now and solve. So we have 2x minus 9 equal to 0, and 2x plus 9 equal to 0. So we add 9 to both sides. 2x is equal to 9, and then divide by 2. X is 9 halves. And on the second one, we subtract 9, so we have 2x equals negative 9. And then we divide by 2. X is negative 9 halves. So there are our two solutions. Quadratic equations always have two solutions. If it's a perfect square, we might get the same solution twice, but we'll always have two solutions. All right, let's continue on. So we have x plus 1 equals 2x squared. This one is not in your notes. We want to keep, and it's not in standard form, right? We don't have the x squared term and the x term and the constant together, and it's set equal to 0. We want all our terms to be on one side, and we want to keep x squared positive, right? So we are going to move the x and the 1. So we're going to subtract x, and we're going to subtract 1. Right, so we'll subtract x and subtract 1. Right, so now we're going to have 0 on the left side and 2x squared minus x minus 1 on the right. Right, and so our a is equal to 2, our b is negative 1, and our c is negative 1. Right, so 2 times negative 1, I'm going to multiply the coefficients of the first and last terms, the a and the c. 2 times negative 1 is negative 2. Right, so that was the product of negative 2 and 2 and negative 1. Right, and so we want two numbers that multiply to give us negative 2, but add to give us the b term of negative 1. Right, well, 2 only has two factors, 2 and 1. If they're if they're multiplying to be a negative number, one of them's negative. If they're adding to be a negative number, it's got to be the larger term that's negative, right? So 1 and negative 2, right? So 1 times negative 2, that's negative 2. And 1 plus negative 2 is negative 1. Right, so we'll just replace the negative x with the two terms we just found. So we have a positive x. You don't really need to put a 1 there, but I'm going to put a 1 there so we don't have an empty space. Oops. Now I hit the board. So now I made a little mark there on my 1. And negative 2. Right? So we've replaced the negative x with a positive x and a negative 2x. Notice it still adds to be negative x. And actually, when somebody multiplied them, multiplied the two binomials together, right? They got an x and they got a negative 2x. And they combined those like terms, and that's how we got the negative x up there. Okay? So remember that factor by grouping is just a distribution process backwards. A little reminder there. That was a closing question at one point. So 2x squared plus the 1x or x and plus negative 2x minus 1. So first to our group, second to our group. Right? So it's just like we're undoing distribution here. We plot our greatest common factor. So x is the greatest common factor for 2x squared and x. 2x squared divided by x is 2x. X divided by x is 1. Greatest common factor for negative 2x and negative 1 is the negative 1, right? Because that 2x has got to be positive. Negative 2x divided by negative 1 is a 2x. 1 divided by negative 1 is a positive 1. Negative 1 divided by negative 1. I think that's what I said. So repeating, 2x plus 1 is one factor, and what we pulled out, x minus 1, is the other factor. All right, and so you notice this is just distribution backwards, right? Because, well, I'd probably have them in the opposite order if we were doing distribution, but notice we have the x times the 2x plus 1, and we have the negative 1 times the 2x plus 1, right? And then if we're multiplying, x times 2x plus 1 would give us the 2x squared plus x, right? And negative 1 times 2x plus 1 gave us the negative 2x minus 1. And then if you add the terms back together, you'd end up with this, right? So all factoring is multiplication by distribution backwards. All right, so let's just finish this off by solving. We have the 2x plus 1 equal to 0, and the x minus 1 equal to 0. So on the first one, you'll subtract 1. 2x is equal to negative 1. And divide by 2. X is negative 1/2. Add 1 to both sides on the second one. X is 1. Those are your two solutions. And we have solved it. I had a couple more. All right, this one is in your notes. We have 2x squared plus 8x equals 5x plus 20. Well, we can't have two x's, right? We got to combine our like terms, and we got to get everything on one side. We want to keep that squared term positive, right? So let's subtract 5x and subtract 20. So minus 5x minus 20 minus 5x minus 20. Right? So when we do that, on the one side, we're going to have a 2x squared. We're going to have a plus 8x. We're going to have a minus 5x and a minus 20, and then we're going to have 0 on the other side. We can combine the like terms. 8x minus 5x, that'd be 3x. So we have 2x squared plus 3x minus 20 equals 0. Right? You got everybody there? Okay, so now we multiply. Actually, let's identify A, B, and C, just so we keep thinking about that. A is 2, B is 3, C is negative 20. All right, so 2 times negative 20 is going to give us negative 40. All right, so we need two numbers that multiply to give us negative 40, but add to give us the B term of 3. Well, let's think of the factors of 40. Right, well, 1 and 40, well, that doesn't work, right? Because they're not 3 apart, right? And one of them has got to be negative, because we multiplied to be a negative number. Well, it can't be 2 and 20, because they're not 3 apart. 3 doesn't divide evenly into 40. It can't be 4 and 10. They're not 3 apart. But 5 and 8, they're 3 apart. Since they add to be a positive 3, it's got to be a positive 8 and a negative 5. Right? So that multiplies to negative 40, and it adds to positive 3. Right? So the replace that 3x with an 8x and a negative 5x, and the first two are a group, and the second two are a group. All right, and the greatest common factor for 2x squared and 8x is a 2x. 2x squared divided by 2x is an x. 8x divided by 2x is 4. Greatest common factor for negative 5x and negative 20 is the negative 5. Negative 5x divided by negative 5 is x. And negative 20 divided by negative 5 is positive 4. This time I'm going to list what we pulled out first. So we pulled out the 2x plus the negative 5. And the other factor is the repeating x plus 4. All right, so the repeating is one, what you pulled out is the other. Now it looks just like distribution, right? So if we were multiplying 2x minus 5 times x plus 4, right, we'd have 2x times x plus 4 and negative 5 times x plus 4. And we'd distribute, right? We'd have 2x squared plus 8x and negative 5x and negative 20. And then we combine the like terms, and that would have gotten us right back to this equation here. Right? And so when we're factoring, we're just doing that same thing but backwards. Right? So now let's solve. So when we're solving, once it's factored, all we have to do is set the factors equal to 0. So we have 2x minus 5 equals 0. And x, shadow was blocking, plus 4 equals 0. So we'll add 5 to both sides. 2x is equal to 5. And then divide by 2. So x is 5 halves is one solution. And it comes. And the other, we just subtract 4 from both sides. Come on. There we go. X is equal to negative 4. Right, and we're all done. I think there's one more on this set. Yeah, one more. And then there's the, no, there's two. Well, there's not even an equation here. So let's do one more. And then we'll look at the other equation and the application problem. All right, so here we want to solve 6x squared plus 4x equals 0. All right, so now we don't have, there's no c. Right? No c term. It technically is an ax squared plus bx plus c equals 0. There's just no c term. Right? So because there's no c term, you're going to use greatest common factor rule instead. All right? Anytime there's no constant, just plot your greatest common factor. All right? So greatest common factor for 6x squared and 4x, well, they're both divisible by 2, and they're both divisible by x. That's our greatest common factor. So we're going to divide these two terms here by 2x, right? And that's going to give us our two factors. 2x is one factor, right? And then what we get, the quotient, what we get when we divide 6x squared plus 4x by 2x, that's our other factor. So 6x squared divided by 2x is 3x, and 4x divided by 2x is 2. And if you weren't sure, you could multiply it back and you get the same answer, right? 2x times 3x is 6x squared, 2x times 2 is 4x. And now we just apply the zero product rule. We set each factor equal to 0 and solve. So we have 2x is equal to 0. Well, if you divide 0 by anything, it's still 0. And we have 3x plus 2 is equal to 0. So we'll subtract 2 from both sides and then divide by 3. X is negative 2/3. Those are our two solutions. And we can always check, and since I didn't do a single check, I'll check on this one just so you can see that it works out. All right, so here, if I have 6 times 0 plus 4 times 0 equals 0, well, 6 times 0 is 0, and 4 times 0 is 0. So 0 equals 0 checks out. And then we had 3 times negative 2/3 plus 2 equals 0. Right? Well, 3 times negative 2/3, those 3's would cancel. Right? So I would just be left with a negative 2. Negative 2 plus 2, well, that certainly equals 0. Come on. Because those are opposites of one another. So 0 equals 0. Both of those check out. That's all you would do if you weren't sure. All right, so that's going to end this podcast. I'll see you in the last podcast.